Hello everyone, and welcome to our next video on functions. Today we're just going to talk a little bit more about this idea that functions are just machines. So in math we have a way of showing you that functions are a machine, but sometimes it's not entirely clear if you don't get your head wrapped around the idea first. So I'm going to start off with the simplest machine I can think of, and that's the machine that takes a number and does absolutely nothing to it. So for example, if I take a 3 and I feed it into this machine and I spit out a 3. Well, we can write that over here on our table that 3 gives us 3. And if we have the number 4, feed the 4 in there, and a 4 is going to come out over there, then we know that when we feed in a 4, it spits out a 4. So this is just a machine that really doesn't do very much. But still, people get confused about the way that we write this in math. So the first step to understanding this really well is to know that in math, we don't like talking about these individual numbers. Because then if I wanted to tell you about what the machine does in general, I'd kind of have to convince you by writing out all the things it does. So it takes 6 and makes it 6, it makes 7, 7, makes 8, 8, makes 1047, 1047, and takes a number b plus 1 and spits out b plus 1. The point is that this would literally take me to the end of time to do this. So I don't like doing that. Instead, I like to just use this letter right here. And this says it doesn't matter what the number is. I'm just going to use any number. Now, we'd like to also separate our machines. We don't want to talk about all the machines at once. I want to talk about this machine, and this is the machine that doesn't do anything. So the machine that doesn't do anything, I'm going to give it a name. I'm going to call it H. Okay, we usually use names of one letter, and this can be a bit confusing because we use letters to show the input. But this one is a name. Okay, this is just the name of the machine. So you're not allowed to get confused about that because we all have a name, and this just happens to be the name of the machine. You know, you have a toaster, you call it the toaster. This is H. And H is not very special because H doesn't really do much. So if we're going to write what comes out of H, we know that X is going in. We need to show you that I use the H machine to do something. And what did I do it to? I did it to the X. So we're going to write our output as H of X. So that's how you read that. That's read H of X. But really what it means is feed X into the H machine. And the H machine does nothing. So this just says do nothing. Okay? So that's all that this is all about. We're just trying to describe what the machine is, what's it's called. It's called H. What got fed in? X. And what does it do? It does nothing. Okay? So we're going to work with some machines a little bit more complicated, but it still works the same way. So how can we represent all of this in algebra so we don't have to keep writing all these machines out? I don't have to draw my machine. When I say a toaster, you know what I'm talking about. So the same kind of thing in math. If you want to talk about a machine, you just need to tell me what the machine does. So we're going to create a machine here that takes numbers. So X takes numbers. It multiplies them by 3. So we're just going to say multiply by 3. That's what's on the inside of this machine. And then it subtracts 4. And then it spits that out. And again, we need to have a name for this machine. So we'll call this one F. Okay, we usually start at F for some reason in math. Probably because F is the first letter for function. But it doesn't really matter what this is. It's just a name. So we take X, we multiply by 3, we subtract 4. Okay? So this machine, that's what it does. And when it spits out a number, we know that it is the F machine that did it. And it acted on the X. So it took the X and did this. And it spit it out. So we can write this with algebra now. We have F of X. Well, what does it do to the X? It takes it, multiplies it by 3. So remember that when the letter is touching the number, that's just a short form for multiply. And mathematicians are lazy. So we tend to write things as short as possible. And so we're just going to write that 3 right next to that x. And then once that's done, what happens? Well, we go into the subtract step of the machine. So it subtracts 4. So this is what comes out. F of x comes out. So for example, if I did f of 2, let's do negative 2. F of negative 2, then what does that do? Well, it takes that negative 2. It multiplies it by 3, and it subtracts 4. And what do we get when we do that? This will be minus 6 minus 4, and we get minus 10. Okay, so down here I have a different machine, you can tell, because it looks different, right? It physically looks different. We'll call that G. This is the G machine. And it takes numbers, and first it squares them, let's say. And once it squares it, it multiplies by 2. And that spits out the result, which we know we're going to call g of x. So let's write out our rule. So g of x can be written as squaring a number, then multiplying it by 2. So let's do one. Let's just say we want to know what g of, I was going to use my colors different. Let's say we're going to use g of, let's just do 1, g of 1. So what happens there? We get 2, and there's our 1, gets put into the machine. 1 gets squared. Now notice that I have to follow BEDMAS. Don't forget BEDMAS. So the algebra I have here is the same as this because BEDMAS demands that we do the squared first, just like we did squared first in the machine. Okay? So we've got 2. When you square 1, you get 1, and 2 times 1 is 2. So we know that g of 1 is 2. So that's what g does to 1. When you square the 1, you get 1. When you multiply by 2, you get 2. So g of 1 is 2. Now, one great thing about functions, when we write them this way, is you can use them to build even more complicated machines. So when I take our two machines we just had, so we've got f of x equals 3x minus 4, and we've got g of x equals 2x squared. So let's first use that to find what f of 2 is. So f of 2 is going to be equal to 3 times whatever that number is that we're feeding into the machine, then subtract 4 from that result. So the number we chose to feed in was 2. And when we do this, that's going to be 6 there, and 6 minus 4 is 2. Okay, so we've got f of 2 is equal to 2. That's a really important fact that we've got, okay? Now, g of 6 we can do as well. So we're going to take that 6. Okay, we're going to take that 6. We're going to square it. Then we're going to multiply that by 2. Okay? Notice that the order again is indicated by BEDMAS now, right? We know inside the machine it squares the 6 first. So that's 36 times 2, which is going to be 72. So we know g of 6 then is equal to 72. Now we can build a machine that is a combination of f and g. So for example, this one here, okay, we've got f of g of 6. Well, what's that really telling us to do? Well, let's look at that as a little small thing here. So if we've got our f, well, inside of that we have g. So we've got our f, which was kind of shaped like this, right? And we've got our g, which was like shaped like this, I think. So what do numbers do? You feed a number in to the, oh, actually, wait a minute. I messed that up. So hold on, let me try this again. This can get confusing. So I did that wrong. So let's try this again. So let's look again back at that. So this says take the number 6, feed it into the G machine and get a result. Once it's out of the G machine, feed that result into the F machine. Okay, that's what this is saying for me to do. Okay, so what I have is I have the G machine first. Okay, which will take a number and spit it out. We're going to take that number and we're going to feed that into the F machine, which will shape like this. Okay, so we'll try to remember what these do. So we take 6 and we feed it into the G machine. But the great thing is we already know how to do that. We know that when we feed G, or 6 into the G machine, we get 72. So let's do that. So this becomes 72. Okay, now we don't know what happens when you feed 72 into the F machine, but we know what the F machine does. The F machine is the thing that multiplies the number by 3 and then subtracts 4. So let's feed that 72 in there. Let's see what happens. So 72 times 3 will be 126. Will be, hold on, is that true? 100 and what? Let's do it together. 72 times 3 will be 6, and that's 21. So sorry, 216. And 216 minus 4 is going to give us 214. So that's what's going to come out the bottom here. So when we feed it into the G machine, we get 72, and we feed the result in the F machine, and it gives us 214. So when we go back here, this is going to be 214. Now we could have done this with algebra instead of writing the machine, right? We know we're looking for F of G of 6. So this is F of, okay, G of 6. Well, G of 6 is governed by this rule here. So we get 2 times 6 squared. Now we already know what the result of that is because we did it over here. So it's going to be F of 72, which is equal to 3 times 72 minus 4, which will be 216 minus 4, which will be 212. That should have been 212. Okay, so that's that general idea of what to do here. This is just telling us the order to do it in. So this, again, we already know what F of 2 is. F of 2 is 2. So this becomes G of 2. So G of 2 is equal to 2 times 2 squared, which will be 4 times 2, which is 8. I know that was a little bit jumbled, but the idea here is just to understand that the instructions are given right there. Okay? This tells you what to feed into the F machine, and this tells you what to do when you get that number. So if you got a 2 here, this is telling you what number to feed in, and this is telling you what to do with that number.